Hello everyone. Today we will learn the number system conversion from binary to decimal and decimal to binary. As we have seen in our previous lecture, the binary to octal and octal to binary conversion. So let's start with, in binary number system only two numbers 0 and 1, and in decimal number system we have numbers 0 to 9. So keep this in mind that these systems are restricted to these numbers. So we have to convert the 0101 system to 0, 1, 2, 3, 4, 5, 6, 8, 9 system. So we will start with the example. We have an example of binary to decimal first. So the example is, this is a binary number and we have to convert it into the decimal. So how we can do it? First we have to write the position of these numbers. We'll start from right to left. So 0, 1, 2, 3, 4, 5, 6 and 7. So this is the first step. After this, what we have to do is, we have to write this base, whatever the base is. As we are going to convert binary to decimal, so here we have a binary number, so we have to multiply it with 2. So it will be 2 and the power of this 2 will be this number. So 2 raised to power 7 multiplied by this digit, this is 0, then plus 2 raised to power this number 6 multiplied by this 1 plus 2 raised to power this number, that is 5 multiplied by this 0 plus 2 raised to power this number, that is 4 multiplied by 0 plus 2 raised to power this number 3 multiplied by 1 plus 2 raised to power this number 2 multiplied by this 0 plus 2 raised to power this 1 multiplied by this 1 plus 2 raised to power this 0 multiplied by this 0. So we have to stop here. Then we have to calculate them. As in this we will get 0 as it is multiplying by 0, so we need not to calculate the whole. Then in this pair 2 raised to power 6, 64. Then as it is multiplying by 0, it will be 0 plus 0 plus, here we again get the 0 plus, here we will get the 8 plus, here we will have 0. So here again we have 0 plus 2 plus 0. So what at the end we will get is 64 plus 8 is 72, 72 plus 2 is 74. So this is the decimal equivalent of the given binary number. So you have to follow this process for whatever the binary number you are given with. You just need to write their value, their positions from right to left, start from 0, and then you have to do the multiplication as it is, as I have given here. So this is the binary equivalent. So this is the decimal equivalent of the given binary number. Now, if what we have to do is, we have to convert now that this decimal number into binary. What method we have to follow in that case? I'll take this decimal number 74 for the ease. This is a decimal number and we have to convert it into a binary, and that binary should be equal to this value. So let's see how we can do it. For that purpose, you have to do a repeated division by 2. How we can do that? Let's see. For that purpose, what I have to do is, I have to draw like this. I have to write the number here 74 and I have to divide by 2 because I am converting this number into binary where we have only two digits 0 and 1. So I have to divide it by 2. How we can do that is, let's write it as 2 3s are 6, 1 carry 14, 2 7s are 14. Remainder will be 0. Remainder will be 0. Now keep this in mind that we have to write the remainder at this place, and that is very important. And that will be actually the binary number that we'll get at the end. Next is, again we have to divide it by 2, as 2 1s are 2, 2 8s are 16, and what left is, the remainder is 1. So I'll write 1 here. Then again we have to divide by 2, 2 9s are 18, and what will be the remainder? The remainder will be 0 as it is completely dividing the given number. Then again we will divide by 2, 2 4s are 8 and it's 9, so 1 is the remainder. I'll write 1 here. Then again we have to divide by 2, 2 2s are 4, and the remainder will be 0 because it is completely dividing it. Then again we have to divide by 2, 2 1s are 2, and the remainder will be 0. So here we have to stop the division. So how we have to note the number is, if I write here as like this. So let's write the number that we get after the conversion, that is 1 0 0 1 0 1 0. This is the binary equivalent of the given decimal number. So it is clear from here that this number and this number are same. So this is the method of converting a binary to decimal and decimal to binary numbers. So this is the binary equivalent of a given decimal number. So keep this in mind. Whenever we get the equivalent of any number, in that equivalent we will get only the digits of that number system. For example, in the binary equivalent we get only 1 and 0 and we can't get any other number, and the decimal equivalent we get the digits from 0 to 9. So that's all from today's lecture. Thank you.